You ready to move?
All right, here we go. Welcome to the Hackaday Podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 235. We'll be looking at Licorice for lasers, manual motors, and reading resistors. This week in the news, we had two contests that wrapped up. The fourth challenge round, the Gearing Up Challenge from the Hackaday Prize, and our own smaller but no less fun Cyberdeck 2023 challenge. The Gearing Up Challenge from the Hackaday Prize is all about making your own tools, and naturally that draws out a bunch of crazy Hackaday hackers, because who doesn't like to make their own tools?
Well, and we probably are seeing some overlap on that, Elliot, because we were just talking the other day how a lot of the cyber decks have gone from being just kind of curiosities to actual tools that people are using for things, right? So
there was one actual CyberDeck-esque thing in the Hackaday Prize round, actually. It was CyberSec Deck 001. Handy mobile platform for hacking, doubles as a server room crash cart. Both useful and pretty sweet looking. I don't know if they entered that in the CyberDeck challenge, ironically. There were a bunch of other sweet tools, some of them more specific than others. Like somebody made a DIY spin coder, which was really cool. It ends up being, high-speed motor control and stuff like that. But he's able to spin coat PCBs with a very, very thin layer of silicone to make them weather resistant, for instance.
And that's silicone, not silicon, right?
Right. Silicon doesn't flow no matter how hard you spin it.
It does at very, very high temperatures, right? So
that's true, I guess. But the craziest one here was, as far as I'm concerned, the most out of the box was Jumperless, which was a jumperless breadboard, and it's made by having just a whole ton of cross-point switches, essentially. And so you don't have to connect this pin to that pin. It does it for you. Fun thing about it is that it also had backlights, so you could see visually which rows of the breadboard were connected with other ones. And I mean, I think it's just totally overkill, but it looks like it would be so fun to use that I have to give them props for that.
I saw that coming across, and so it kind of comes full circle to last week. You and Tom were talking about the copper pipe breadboard system.
Yeah, right.
From 1974, and so you go from that to cross-point switches and backlighting. So yeah. We live in the future, Elliot. We live in the future.
It is like living in the future. So anyway, we wrote those up. You should go check them all out. There are 10 of those. Right now, we are in the middle of the Anything Goes Wildcard Challenge. So if you've got a last-minute entry for the Hackaday Prize and it didn't fit any of the previous 4 categories, it pretty much fits the Wildcard Challenge. So get on out there, enter it, and you got a chance at winning $500 if it's one of the 10 finalists, and a heck of a lot more if it goes on from there into the final round. Slightly lower key on the prize front, but extremely well entered, was the Cyberdeck Challenge. We did this last year, and it just hit the zeitgeist, I guess. We had like 100 and something entries. This year we did it again, and we've got just about as many, and some of them were truly, truly impressive. The first place entry, Svaichai 1, is just amazing, both from a kind of a modularity usefulness perspective and also a crazy aesthetic style. Just absolutely beautiful. Every one of our judges who judged this one rated it their first pick. So kind of unanimous vote. So
wow, that hardly ever happens.
It doesn't actually. So yeah. Congratulations to MKDXDX for the craziest Cyberdeck build of 2023. Another one that people really liked was a micro PC, which was just a tiny little luggable PC on a piece of, looks like laser cut acrylic or something. It's just so cute, and it's kind of maximum PC squeezed into minimum amount of space. I think everybody liked that one. And the total opposite end of the spectrum was Top Lap, which had a cut steel chassis and used or required, I don't know which, but gas springs on the hinges to open and close the screen. It's a full-size monitor screen and like beefy speakers. It's a 7 amp hour battery. Like it's hardcore. it's luggable if you're Mr. Universe, but it has everything you could possibly want. So that's really fun.
I needed a picture of Tim Allen on it saying needs more power and grunting, right? So.
Yeah, right. Putting it in steel it's definitely making a statement. Other tremendously beautiful builds in this one. I have to give a shout out to Robson Kuto's portable terminal because it's really sweet and uses a vacuum fluorescent display screen, which is very cool looking.
That was pretty.
Solar box built by Nick Scratch is actually really cool. It runs on solar power. I mean, it's got a battery for backup, of course, but it is basically a solar powered computer in some kind of absurd wooden box. I don't know what that's about. E-ink is what he uses for the screen, so it doesn't draw so much power. And I guess it's also got one of those fun sharp memory LCDs as well that also use very little power, but gives him something that can update a little more frequently than the e-ink. And so you can display on either of them. Pretty sweet, and the whole thing runs off of sunlight. Anyway, big week in Hackaday contests. Go check out the write-ups of those because each of them contain 10 projects that will amaze and astound.
This is a journey into sound. What's that sound?
What's that sound?
Oh, which brings us to, what's that sound?
We need to finish up any of the labs. You left off on lab 5, B17.
It almost had to be something rotating and like a pawl flipping back and forth, but I had nothing better than a pawl. I am appalled. There you go.
Oh my God. Well, this is the one that stumped everyone. This was actually an idea submitted by FedEx over on Discord. And once I told Tom what it was, he was sure you would get it. He said you would 100% get it.
Really?
And yet, I thought it was too much of a stumper myself. It was actually a real live Enigma machine. The noises that sounded like, I guess that was your Paul, was typing into an Enigma machine. And at the end, there's a little bit, like a super subtle little bit of ratchety noise, which was them changing the rotor setting wheels. Once you see it and watch the video, it's actually pretty obvious what it was. So we'll throw a link to the video we got it from in the show notes so you can go ahead and watch someone operate an Enigma machine.
Are you sure no one answered correctly, but they just sent the answer in encrypted and you weren't able to read it?
So many people answered staple gun. And if staple gun is secret code for Enigma machine, then they all got it right. That's really impressive. A parcel sorting robot? That's a good guess. It's people talking. Unfortunately, the challenge is made harder by the clicking noise. yeah, that is the problem. So, best answer to David M.H. There were some people talking in the background. I mean, it was in a museum. Anyway, this has never happened. No winners for the What's That Sound contest. I'll have to come up with something significantly more obvious for next week. So stay tuned for your chance to guess and win. All right, well, my first hack this week comes from Michael Rechten. Hefty 3D printed quadcopter meets nasty end. And this is kind of 3 videos in a row where he's documenting building an entirely 3D printed quadcopter. And if you are like, this is clickbait, it's not entirely 3D printed unless he 3D prints the motors. Well, he did 3D print the motors. And that's actually the first video in the series is showing him doing all the design for that. That's not to say they don't have metal in them. Of course they have coils and of course they have magnets and they've got bearings. You know, there are all the metal parts you'd expect, but the bell and the housing and all of that is actually entirely 3D printed. The motors end up being really big, however, because of this. I mean, they end up being, I think, 1 kilogram per motor. And he says when he fires up all 4 of them, it consumes 2,500 watts. So it is just slurping out of the batteries. And he has a ton of batteries in the thing, but that, of course, is nothing compared to 4 kilograms worth of motor weight. The frame's also 3D printed, and he really wasn't concerned about weight in this build because it's got like a 3D printed hatch on the top, and it's got all sorts of knickknacks that I would have taken off for weight savings, but not Michael. And because of this, it gets about 2 minutes of flight time, But here's the point. He 3D printed this thing and it gets 2 minutes of flight time. That's pretty crazy.
Yeah, it's not that the talking dog tells a bad joke, it's that he tells the joke at all, right? So, I had a lot of thoughts on this one. I really liked the look of it. I thought it was very aesthetic. And I think some of it was the weight savings on the 3D print, right? Because he's got a lot of, it looks almost spidery or gossamery or whatever you want to call it. And honestly, it reminded me of dragonfly wings, which I thought was very appropriate, right? Kind of had that spidery look. I don't know if he did the finite element analysis to figure out where you didn't need material, or if he just guessed, or if it was, I didn't follow that to see where that came from. But it's still at 12 pounds. So I'm not sure removing, 16 grams of polymer out of each arm was really going to make a big difference. But I thought the effect was really cool. I once had a quadcopter incident where basically a DJI clone, it was one of those big, heavy drones, decided to go off scale and just shot up like a rocket, and then about 5 minutes later just crashed to the ground.
Oh, shit.
And I'm thinking, I don't really want a 12-pound thing in the air over me unless I'm really sure it's not going to crash, right? That was a scary moment. I actually recovered from it and wound up not killing anybody, but that was not always apparent.
Yeah.
So I don't know if, I applaud it, but boy, I'd really be careful flying a 12-pound, even for 2 minutes, a 12-pound drone over anything, basically.
Yeah, and when he's tuning it in his backyard in the beginning, right, and he doesn't have the PIDs set right, the thing is absolutely terrifying. And it ends up being made worse by the fact that one of his motors is actually a little bit sticky and weak compared to the other one. So he ends up reprinting it, which is kind of a cool thing to say. It's like, that's a bad motor, I'll just reprint it. But on the other hand, I think it takes him 12 hours of print time and who knows how much labor to do it. It's still probably easier to just get it off of AliExpress. I don't know. But yeah, no, this thing is a beast and you have to be careful with it. The way the arms look, it is done with a finite element analysis generative design thing. And that's really cool, at least for the way it looks. And I think I actually totally agree with you. We've actually seen a bunch of generative design stuff. There was, in fact, a 5-axis 3D printer entered into the Gearing Up round for the Hackaday prize that we just wrote up recently. I'll throw the link in for you. That's also done with generative design. And some people point out in the comments that it doesn't make much sense for a 3D printer because you don't have to reduce weight there. I don't even know if you're reducing weight on these quad arms because it doesn't take into account that it's going to be a 3D printed part. That is, that it's hollow essentially on the inside where the infill is, and only weighs on the outside. And I don't think these generative design algorithms do that. And what they really don't do is take into effect that it's a 3D print and the z-axis is weak relative to the x and y. In this video, Michael runs into that and one of his motor mounts breaks because it comes delaminated, right? The different levels of the 3D print come apart. And so that's another thing that makes me think the generative design is just for show. But damn, it looks good.
But I do think there's a lot of legs to that in the future, simply because as you move away from polymers, if you're 3D printing in, say, titanium, being able to get rid of 40% of it saves you a ton of weight. Well, shouldn't say a ton of weight, a lot of weight.
Yeah.
And also a lot of cost and processing time and everything else, right? So, it's one thing to say, well, I saved 4 grams of PLA that cost me 0.05 cents a gram or something. But it's another thing to say, well, this very expensive metal process that will help you a lot with that. They make a material that's actually like a thin metal plate on both sides and then honeycomb metal on the inside. So they're thicker, but they weigh a lot less for something of the same structural strength. And they use that like in aircraft and spacecraft and things like that. So I think we'll see a lot more of that as the community moves off of polymer or, moves into other areas. I don't think we'll ever move completely away from polymer 3D printing, but everybody I know would like to be able to 3D print in metal, right? So,
and the SLA prints, the resin prints also don't have this bad z-axis anisotropy, whatever. SLA prints also don't have the weak z-axis problem as much, and so they fit this generative design process a lot better. but not even to mention metal sintering like you're talking about. But that brings us to the last thing I'd like to say, which is this thing is heavy. It's a beast. It ends up exploding not because it fails while he's flying it, but actually because he wants to mount it to a tripod to take beauty shots of it for his YouTube video, and he drills through into the lithium polymer battery with predictable results.
Whoops.
Unfortunately, he didn't catch this on video. So A, it's not staged, but B, we don't get to see the thing going up in flames and the look on his face as he drills into the battery pouch. Whew, that's a bad day. But what I do want to say is this thing is a pig, and it is overly heavy and underperformant because it's a first step in this. And we saw that not, 5 years ago with kind of 3D printed RC planes. And then along came lightweight PLA and improvements in designs, improvements in the actual 3D printing methods themselves. And nowadays, people can make 3D printable airplane frames no problem. It's much more commonplace. And I'll throw some links to Hackaday coverage of this. But this is something that developed in kind of 3 years, 5 years time frame. So I wouldn't be totally surprised if this happened with quadcopters too.
Paradoxically, my next one is from Projects in Flight, although it has nothing to do with quadcopters, so I'm not sure what that means. But the post was growing oxides on silicon on the road to DIY semiconductors. If you look, he's had a couple of different projects coming along that are kind of the prelude to trying to fabricate his own semiconductor devices. And in this installment, he's done a DIY tube furnace, which is a fused quartz tube with a whole lot of electrical resistance heating and lots of insulation. And you might say, well, he made an oven, big deal. Well, the oven gets to 1100 degrees centigrade, or Celsius if you prefer. And so that's really, really hot. I think that's the scientific term for that, is really, really, really hot. I think why I'm interested in this, though, I'm not that interested in the oven, but, I worked in the semiconductor business many years ago, dissecting microprocessors to see why they failed. And so we were involved in this sort of stuff. And honestly, it's not that hard to understand if you start digging into it on that level. The problem is it's so hard to do because you need all these wacky specialized things like a tube furnace, right? And cylinders of exotic gases that are not always, silane and all this stuff that maybe is not all that good for you to have around the house. I think what I'm always interested in this sort of thing for is, you think about it, there was a time when saying, well, building a remote control airplane would be very difficult. Well, now it's not. Or having a computer in your house would be almost unheard of, and now it's not, right? Working with FPGAs was, so are we going to get to the point, and I think the answer is yes, where maybe not everybody's able to make their own semiconductor devices, but are we going to eventually get to the point where that's within reach of somebody like a Hackaday reader, right? We've already seen it done at least once or twice, and I think we're going to see more of it. The real question that I didn't see out of this that I would be interested in knowing more about is how repeatable the process is, because you do see that a lot in commercial semiconductor fabrication. Like if you did a competitive analysis, you could kind of tell where the parts originated based on whether they had a wide variation of oxide thicknesses versus areas of the world where they are kind of sloppy and take a lot of coffee breaks and go, oh, I think it was 3 minutes. Yeah, they had a lot of deviation in the samples, right? And if you were in the places where they followed directions to a T, those parts would have very tight tolerances across a batch of parts. So that becomes very critical for both yield and also just characterization of the parts, right? I mean, especially on analog stuff, if the oxide's twice as thick, then the capacitors are going to be half or twice the value, depending on the way you look at it. So I'm really interested in following this through the end and see if he's able to produce workable devices. I don't think anybody's going to be doing sub-nanometer CPUs anytime in the near future, but I do think we could start seeing people with the capability to do, say, custom op amps or, pretty simple devices that, granted, the industry was doing decades ago, but with millions of dollars of capital equipment. And I think it's cool that people can do it in their garage.
Yeah, absolutely. And I mean, most of the video that we've linked here is about how he figures out how thick the oxide layer he's getting is. And I don't know, this is one of those where you just really need to go look at it. It's all about the color it reflects back at you. And he goes through that, and there's some ambiguity there. So he goes through how he figures out what part of the rainbow he's in and stuff. But really, it's just extremely pretty. And I have to say, if you go through all this trouble of creating a silicon oxide tube furnace like this, it's at least nice to get some pretty little silicon samples out at the end, right?
Yeah, you could probably sell these bits for jewelry on eBay. Right? Somebody would
Jeez.
put them on earrings or something.
You've worked in the industry, I haven't. I honestly can't imagine how tweaky it is to make a tube furnace like this actually do its job. It strikes me as black magic.
Well, think about this. I mean, we've probably all got 3D printers, and if you've ever had to rewire your hot end, you know what a hassle that is, because if you're too close to the hot end, it melts your solder.
Right?
That's 200 and some odd degrees C. This is 1100 C. So everything's got to be different.
Yeah.
I've never built a tube furnace. I've bought them, but I haven't built them. But everything's got to be different at 1100, right? It's just not possible.
Even at printer temperatures, even at coffee roaster temperatures, everything's crimped, right? Because your solder comes undone.
We're not talking about your fire again, are we?
We were for just a second. Everything's cool. It's all better. So we've got now 3 people working on DIY semiconductors.
Well, the other thing that'll be interesting with that too is, they're, like I say, they're not going to get to sub-micron geometries and everything. And when you've got fairly large geometries, there's lots of interesting things you can do just with an optical microscope, a needle, and, pretty basic tools as far as doing things like optimizing your process, trimming resistors to match things. Things that you can't really do anymore in, quote, the real world, unquote, because everything's upside down for heat transfer and you can't see it optically anyway anymore. So, stuff like we used to do back in the 80s, you could do again with these kind of home setups, I think.
All right, my next hack is a laser hack from Les Wright. He's unstoppable. This one is electro-optical control of lasers with a licorice twist. And what's going on here is he's making an optical switch, that is a way to block and pass laser light through, using the Care effect. And what's cool about this is that you can make it opaque and transmissive on kind of the nanosecond time scale. So you can let through really short pulses of laser with it. The way it works is a really strange effect. There are some fluids that when you put a high voltage across them become differently polarizing than they would be with no electric field across them. And so you use this by putting cross-polarizing filters at the front and the back. And then when you turn the voltage on, it gets spun around a little bit while it's inside the fluid and transmits out the end. And when you turn the field off, then whatever passes through the first polarizer gets blocked by the second one. And that is the Care effect. The question is, what kind of fluids have this property? And the first one that Les looks into, and the one that's used in professional Care devices, Care switches, is nitrobenzene. And he spends at least 3 or 4 minutes telling you how awful a chemical nitrobenzene is and how he doesn't want it anywhere near him. He finds another chemical, anethol, which is the extract of anise, that also behaves this way. And so he buys some on the internet and tests it out. And it actually works. And so with a reasonable high voltage power supply, I think he's, a few tens of thousands of volts across a cuvette that's filled with this anethol in it, he can get it to become polarizing and not. And it's a really, really cool effect. He's got some kind of crud in the anethol, and once he turns the juice up, you can see these strings kind of left over that don't unpolarize when he takes the field away. And I think that's some kind of funny impurity he's gotten there. But still, the whole thing basically works, and it's a really kind of crazy way to turn on and off a laser without actually turning the laser on and off at all.
So the more I read about light, the more I'm convinced we don't fully understand physics. I couldn't put a reference to it, but, I once saw that if you have a coil of fiber optic with a coherent light source through it, it'll detect a magnetic field. And it's like, really, how could that work?
Right? Yeah.
So I guess this is the same thing. I mean, I'm thinking, first of all, who figured out that the licorice extract is able to do this at 45 kV? That seems like an unlikely.
You know.
Who's in a lab going, hey, let's just try this? I don't know.
So
what if it was at 50 kV?
Kerr discovered the effect at 180 kV with nitrobenzene. So what's more likely there in the 1800s? So.
Yeah.
Yikes.
Oh, I wonder, did they know that it was, as Dan put it, a distressingly powerful organic solvent? It may have been they didn't know what they were messing with, right? I don't know.
I have no idea.
It just seems like such an odd thing to try, right? I mean, what about baking powder? I don't know. What else what else could you use? Why not? Why? There's got to be somebody that understands what the molecule shape is like this, and that's what causes that to happen. But that's beyond my meager abilities, I'm afraid. Everything I read, though, says that, that's the next step, is using light instead of electrons for everything. So I think this kind of work is important, although probably won't be that important to the hobby community for a few more years. But I'm really interested in seeing where this kind of stuff progresses.
I think it is useful to the laser hobby people out there now, because I've encountered it in trying to make a laser light show, is how to turn the laser on and off. There's a class of lasers that don't mind being turned on and off quickly, and then there's a whole bunch of them, like all the ones with frequency doubling crystals, which glow for a little while, which you honestly just can't turn off really quickly. So those old school green lasers, for instance, if you try to make a laser show with them, you always get a little green ghosting afterwards because you just can't turn the green off as fast. And so this is one of those things that people doing laser shows or screwing around with lasers for other reasons really worry about, is how to leave the laser continuously running and then block it off and let it through. And one of the classic solutions to this, I'll throw the link in the show notes, is an acousto-optic modulator, which is pretty cool too. You basically take a clear crystal and you vibrate it really fast, and that deflects the beam a little bit. And so you put a beam block up in the deflected place and you let it pass through a hole in the undeflected state, and you can use that as a very fast laser switch as well. And that's kind of what I've seen used. And I think the reason I've never seen a carousel used by hobbyists is because this whole nitrobenzene thing is just hella dangerous. And so I do think it's really interesting that Les is playing around with kind of an alternate way to do hyper-fast laser optical switching. So I think it actually isn't even that unpractical. I think there will be some laser show people out there who will think this is a pretty cool bit of work he's doing.
Okay, my next one is from Maiku. Make better 3D printed molds for thermoforming plastic. I built a 3D printer a long time ago, and I have to confess, I still occasionally just stop and watch them go, and I'm fascinated by the whole process. I think part of it is, we're seeing this really golden age, if you will, where people can build stuff very credibly that would be almost impossible to do prior to having all this technology. So if you think about it, I mean, it's almost like we were talking about the semiconductors, right? It used to be if you built something, it looked like everything else everybody else built because you probably bought the same box everybody else had, and you drilled some holes in it. And no matter how smart you were about the inside of it, the outside still looked like every other piece of home-built gear. Now, with 3D printing, we're seeing a lot more presentable-looking things, stuff like the cyber decks and things where they're taking advantage of that. Injection molding, thermoforming, those still aren't as mainstream as additive manufacturing that we're seeing, but I think we're seeing more and more people get into that. So the fact that 3D printing can actually enable you to get into things like thermoforming and do decent without having to go spend, $100,000 on somebody's die or whatever, I think that's a real game changer. I'm not a very mechanical person, so, I'm lucky to get any kind of good result mechanically. I'm more the hardware and software guy, but I really applaud that people I know can now make stuff that you would not think twice about if you saw it in a store shelf. And you might say, well, that's just vanity, right? What difference does it make? But actually, there's a couple of differences. I mean, we've talked before about the spouse factor. Yeah, I can't put my wonderful home automation system on the shelf if it looks like it's built on a breadboard with a bunch of DuPont wires hanging off of it, right? But if it looks nice, maybe I can get away with that. The other thing is if you're unabashedly capitalist, I can't believe it doesn't look better to take some nice looking prototype in to ask for $1 million or $100 million or whatever you're asking for than it is to bring in some bundle of wires and a bud box with some off center holes drilled in it, right? So I think in both of those cases, there's real practical benefit, not just the vanity or aesthetics of it to be able to do stuff like this. So great job to these guys that are kind of helping push that along and give us more manufacturing technology in the small shop.
Yeah, and I think thermoforming is one of those things that not many people do, but it's actually deadly simple in terms of you need a box that can hold a vacuum, and that can be just a box that's well sealed with some holes in it, and the vacuum can really just be a vacuum cleaner. It's not high tech. You need to figure out a way to heat up the plastic, and then boom, you put it over your mold, turn the vacuum cleaner on. It's something that a lot of, model maker hobbyists, for instance, have been doing for a long time. But somehow that's a lot of setup just to make little plastic shells. And I think that part, plus the difficulty in making the positive model and making the buck that you want to then flatten the plastic around, you need to carve it out of wood or make it out of plaster or whatever. It's hard work unless you're able to 3D print it. And so I think there is some kind of synergy going on here between the kind of higher tech additive and then the lower tech thermoforming. And I'm stoked to see the one helping the other.
Well, yeah, lost wax casting is a key culprit there, right? It's not that hard to do, but making the original piece of wax is...
That's sculptor's work.
Yeah, if I can push the button and it pops out a piece of PLA in the shape that I want, then I'm done.
Yep.
The rest of it's just no more difficult than, say, cooking a cake from a cake mix, right?
And bringing up the rear from me, RoboHub, Arduino-powered trap hopes to catch mice. This is the continual story of man's attempt to build a better mousetrap. This one, I'm not sure it's better, but it looks pretty fun. It's basically a slapping shut door that's held open with a rubber band. The rubber band is pulled off like a trigger by a servo motor. Whole thing's controlled by an Arduino, and it is triggered, and I think this is actually the clever part, by an ultrasonic sensor, one of those SR04 models. So there's no platform the mouse has to stand on. There's no bait that he has to take. He just has to walk in the right place and then shloop, it closes on him. And I think that's the success out of this. I think I went looking through the write-up and it hasn't actually been tested on real mice yet. And this is where my skepticism comes in, because real mice are significantly smarter than you think. We had a mouse in our basement and I made 5 or 6 different cockamamie contraptions to catch this thing, and not a single one of them caught it. And they were all equally inventive as this one. And the mouse just was like, I'm not going in that thing. There's no way. Part of me wonders if mice can hear the ultrasonic sensor chirps and would just stay the heck away from it, no matter how much it smells like peanut butter.
I wondered about that too, because I thought that was an odd choice. I think I would have gone for a PIR sensor, even if you had all the same mechanics. And, they're super sensitive because they're looking at the differential in heat. Mm-hmm. Mice give off heat. I would have thought you got fewer false positives and not have all the, they're totally passive, so you're not emitting anything.
That's a good one.
I don't know. It'd be interesting to see. And I think somebody made that comment also, but I had thought that even before I saw the comment. Yes, Bruce said a $5 PIR sensor and a solenoid will trip the gravity-assisted door, works 100%, verified by 10 mice.
All right. That's the kind of real-world experimenting I wanted to hear.
But now somebody else says, well, they false trigger due to sunlight. But I don't know. I haven't seen a lot of false triggers on PIR sensors, unless you just have something, you strike a match or something, sure. But
yeah, we've had no shortage of better mouse traps thought up on Hackaday, and I do think it's actually really fun. I think it's maybe more fun to invent crazy ways to catch mice than it actually is necessary to catch the mice. There's a great post from 2017, conflict escalates between Brilliant Rat and 555 Timer. This one is just full of insane rat trap designs, including one where he had it walk across a pole to get a piece of food, and then he put like a rug or something, or maybe it was like an old rag or something over the tube, and then yanks it out of the way, hoping to pull the rat off the tube. And he has this video where he's doing frame by frame analysis, and you can see that the rat has jumped off of the moving surface within 120 milliseconds and jumps and lands successfully on a thin steel pipe nearby. The rat is like super acrobat. This is a sweet video by Casey Connor. You should go watch it just because it's the whole man versus rat dilemma. Another one that I really liked was from back in 2015, building better mousetrap with the Raspberry Pi. This one used a Raspberry Pi camera and a motion sensing algorithm on it to figure out when the mouse was in the box and close the door. But because it's using a Raspberry Pi as the trigger, this one also takes a picture of the mouse and then emails it to you once it's captured. And I just thought that was such a sweet detail. I mean, as long as you're going to have a Raspberry Pi in there, you might as well let it send you a mugshot.
That's hilarious. Are we going to have a Hackaday contest for the best Rube Goldberg mousetrap?
Oh, building a better mousetrap. I think I'm going to have to not say this because we're going to have to actually do it. I don't know how we judge it, though, is the problem. Like, can we test them out on actual mice? I don't think so.
I think we have to have a simulated mouse. You could get Voya to build a robot mouse.
Yeah, the difference between theory and practice, right?
That's right. Well, my next one was Teaching Tech, who had the 3D printed, and the title says, hook and loop fasteners, because in fact, Michael, the guy at Teaching Tech, said it's 3D printed Velcro. But of course, since Velcro is a trademark, you can't actually 3D print Velcro. And it's kind of an interesting story. I guess Printables had a Velcro contest, and I think the intent there was 3D print something that you incorporate Velcro into, right? So you print something, you put Velcro on the back of it. But several people had entered with actual 3D printed fasteners integrated into a design. So he got very interested in that, started experimenting with it. And it was just really interesting. Some of it was maybe hard to bridge your disbelief that it was Velcro because it was actually kind of large interlocking pieces and they had to line up pretty well. You know, that's the nice thing about Velcro. It's pretty random, so you don't really have to line it up too much. It just kind of sticks. Some of it was pretty fine and, you know, looked a lot like Velcro. So if you look like on the YouTube video, the little teaser image, and you can see, I mean, you can tell it's not really Velcro, but it's pretty fine detail. So he actually did some work on trying to figure out what would make this the best. And he tried different materials. Turns out, you know how PETG is often stringy? Well, the stringiness actually helps this. So you actually want it to be stringy. Turn your retraction down so that it gets even stringier, and it makes for a better bond on the quasi-Velcro. I did want to look at, and I haven't had a chance to play with it myself, and I probably won't, but I wish they had looked at, is it one thing to have the hooks made out of a harder material like PETG and the loops made out of TPU or vice versa or something like that? And as far as I could tell, he didn't do that. He had like both pieces were made out of PLA, both were made out of TPU, both were made out of PETG. TPU, as you might have expected, didn't grip real well together, but I'm not convinced it might not grip better against something harder. But I don't know that. That's just intuition. So he actually provides OpenSCAD files where if you wanted to put this into a design, you could. And so that opens up a lot of interesting things. He really took and made some sheets of this stuff and then cut out shapes and things. You know, I think the real key to this would not be cutting out shapes with scissors from a block you printed out, because I could just go to the store and buy a piece of Velcro if that's what I wanted to do. But it seems like being able to integrate Velcro-like fasteners onto something I'm 3D printing anyway in some unique shape or curvature, that probably has interesting legs to it. So I was kind of interested in that. I did take the liberty, because I wrote this one up, I took the liberty of linking to the really great video from Velcro, the Velcro company 5 years ago, where they were begging people to stop calling everything that looks like Velcro, Velcro, because it's their trademark. And if you haven't seen that, hats off. Those are about the funniest. I'm sure they're not really lawyers. They claim to be lawyers, but obviously the lawyers signed off on it. So Really, congratulations to those lawyers for breaking a stereotype. It's awesome video.
I really like your idea, though, of printing the two different sides in different materials. And all the prints here are completely symmetric, right? Like the two pieces look exactly the same and are printed out of the same material. But half the trick with Velcro is that the hook side and the loop side, I mean, the loop side is just fuzzy fabric, and the hook side is all those little plastic hooks. And so I think there's got to be legs there in doing a two material print where you do one in something harder and one in something more flexible, and you can kind of squeeze the flexible one into the spaces between the harder ones. I think that's a great idea. And it'll end up being like some kind of mega version of the mushroomy ones, which no one of consequence in the comments says is called Dual Lock TM. So those are really fun too.
Oh, I was going to say, that's not very nice of you, but I see it's actually the name is No One of Consequence.
Yeah, sorry. This is...
I thought, wow, Elliot's really not in a good mood today.
And if any of you are wondering why we put hackers' handles in the square brackets, it's because someone is going to come in with no one of consequence. And at least in print, you could tell the difference. I put that in Hackaday square brackets when I said it. Bracket,
yes, of
no
course.
one of confidence, end bracket. Anyway, I think this is really cool, and it's a way of connecting 3D prints that we don't see used, and I have no idea what the application of this is going to be, but there are tons of times when I make two parts and, I put screw holes on it because I know I'm going to screw the one part to the other part later. And if this is one of those cases where the orientation worked out right, that you could just print a Velcro-y surface on one and on the other, then boom. And what you were talking about with the randomness of Velcro, I think if you're doing it on your Velcro shoes, it's of course an advantage. But if you're trying to get two 3D printed parts to mate with each other at a specific angle, then Velcro's randomness is a disadvantage. And the kind of regular patterns that Michael from Teaching Tech is talking about here is actually something you could use to your advantage. So I'm thinking of some kind of a part on a 3D printed linear rail could have this Velcro stuff on it. And then, the thing you want to adhere to the linear rail could have the other part. This could be totally useful, actually.
Well, and also if you're doing it algorithmically, like with OpenSCAD, I don't think his OpenSCAD file does it, but you could in fact randomize it. The larger one is probably not good to randomize because obviously it does require some alignment. But if you had a fine enough print, you could actually just introduce some jitter into it and get that randomness out of it.
Or you do it non-random, but algorithmically so that it only fits together when it's in the right orientation. You have Velcro that only fits dead square. Ooh, well, that's going to be cool. Someone will do it.
Another Hackaday patent. Well, it's funny. They do use Velcro in spacecraft, but not as much as people think. And the reason for that was after the Apollo 1 fire, that was found to be one of the things that made it as bad as it was that it was full of Velcro.
Oh.
And I guess in pure oxygen, real Velcro is extraordinarily flammable. So I'm sure it would have still been a bad day and maybe even the worst possible day, even without the Velcro. But ever since then, there's been real limits to how much Velcro you can put in a space capsule. That may be a cutout because that probably doesn't really apply to this. But
yeah, but it's a thing I learned today, so maybe I'll leave it in. My first quick hack comes from Tom Farnell. It's numbers all the way down with this tape measure number station antenna. And I had to pick this one because this is the funniest title of the week. It's a tape measure, so it's got numbers on it, and he's doing a number station. Anyway, it's also a cool hack. In this case, Tom was trying to get down into the low bands, and so he took two 7.5 meter tape measures and unspooled them all to get a giant 15 meter antenna out of it. Tape measure as antenna is a classic hack. It rolls up, it's made out of metal, radiates kind of poorly, but who's complaining? This is a nice iteration of that, and it's plugged directly into an SDR used to listen to number stations. Next up, Mike with his project, finally a machine to organize resistors. This is the Resist Organizer, and this is a project gone all wrong. This is scope creep left, right, and center. The resist organizer plugs into a breadboard with 48 different pins, and you can plug resistors across each of these 48. So you can plug in 48 different resistors, and it reads the values off of them and tells you what they all are. It does this by using a bunch of 4051 multiplexer chips, both to select which resistor it's reading and to select the resistor that it's using in the other side of the resistive bridge. So, you can imagine if you want to test a super high resistance resistor and then a low resistance one, you want to have a different value on the other side making up the resistive divider so that you can maximize your ADC resolution. He actually does that also with some more multiplexers. It's a sweet, sweet build. It's way overkill. I have no idea how you'd use it, but I love to see it.
People will go to any length not to learn the resistor color code, is what that tells you, right?
Tell you what, I buy SMD parts because they just wrote the values on them with numbers. And last up, Svartafall QC. Spooky Noise Box has post-Halloween potential. This is really fun. It's a hollow wooden box with a bunch of piezo transducers on it that he uses as microphones. Whatever else you put on top of it, you kind of make it as spooky as you can. Springs, scratchy metal things. And then you can play it during Halloween to make ghosty, spooky sound noises. I think that's kind of fun. He runs it through a bunch of audio effects. And this is also my chance to drop our listeners a quick tip. We're going to be starting up a Halloween contest next Tuesday. So be sure to check out Hackaday if you have some spooky hacks of your own.
Okay, quick hacks for me. Diode Gone Wild. I love that name, if nothing else. And if you aren't making your own relays, and this kind of goes back to like the 3D printed motors on the quadcopter, he decided he wanted to make his own relays. Not everything. He's getting wire off of old disposed things and, wound up winding them on a bobbin. And what I was a little disappointed with was he actually was using reed switches for the contacts. So, of course, that's another piece of commercial item. Kind of not exactly, but still making your own relays. And it was kind of interesting. He does talk about how to come up with what's the right size of the coil based on what you need. One of those things, you're never going to need it. It's not practical, and yet great fun. Next up, Gabriel Anziani has an interesting piece. Apparently, Kickstarter 10 years ago, he offered a oscilloscope watch. And I don't know about you. I've always thought that'd be cool, right? Have a scope right there. And I guess everybody funded the Kickstarter. It didn't go anywhere, and they kind of forgot about it. And here, 10 years later, they start showing up in the mail. So people are starting to get their scope watches. And speaking of nerdy accessories, my third one is from Blenry, who had the hands-free compass uses haptic feedback. And what that amounts to is it's a belt that kind of tells you which way north is. So just in case the slide rule and the pocket protector were not enough to mark you as a nerd, you can have the belt that points you to north. I just thought that was somehow undeniably nerd cool.
I actually know someone who did that way, way, way back in the day. She had a bracelet on her leg, on her ankle, that was always pointing north, but it only had 4 buzzers instead of 8 like Blinry's does.
I hate to disillusion you, Elliot. She was actually just a felon. That was the story.
Yeah, right? Exactly. What's that crazy orange thing around your leg? All right, it's time for our Can't Miss articles. These are long-form articles written by our fantastic Hackaday writing staff. This week I got Maya Posh's On Vim Modal Interfaces and the Way We Interact with Computers. And this was kind of inspired by the passing in August of Bram Molinar, the man who wrote Vim and kind of kept the old school VI torch burning into the modern era. And it is kind of amazing that people are still using this old school editor that dates back to like 1976 when Bill Joy wrote VI to improve on the old EX editor, which was like strictly line by line and was kind of the right editor for the teletype era. VI was then the visual editor that was useful for, phosphorus CRT screens. So anyway, Vim still exists today. I actually have used Vim, I guess, exclusively for the last 12 years. And one of the weird quirks about it is that it has these modes. And that's what Maya's writing about here. And she writes about it, I think, overwhelmingly positively. And I kind of agree with her, but not 100% either. So if you don't use Vim, the game goes like this. You press I, and then you can type what you normally think of as typing on a word processor. And then you hit escape, and then you can type commands in. What's weird about this is then if you want to type more text, you have to hit I again and enter insert mode. So you're always switching between insert mode and normal mode, which is what the command mode's called. And I think that alone tells you what you need to know about whether Vim is for you. Do you think of editing text as being kind of a programming exercise? If you do, can, or want to, then maybe it is for you. But I think this kind of modal concept that you switch between different modes of interacting with the editor was really confusing for a lot of people. And I think that's kind of the reason that all of the modern text editors don't do that. They've just got one mode. It's always in the you type an A and an A appears up on the screen mode, not A opens up the append mode or whatever, right?
So we're going to have disagreement on this, since you and I have famously had the Vim versus Emacs argument in public many times. I think what I liked about Maya's article, though, is that, you're really thinking about how do you want to interact with the computer? And maybe your answer is Vim, maybe it isn't, but at least you should think about it. Why is it this way? Well, it's because of, your choice of old editors. I think Bravo was the editor that influenced him to do that. Stallman had Techo in the background for Emacs, right? Did anybody really sit down and think, what is the optimal way to do this? Or do they just organically grow from whatever the programmer thought about? And I think that might be the real story here is, are we really thinking about how do you want to interact with stuff? Just on a personal note, I know VI because you almost have to. I also know EX because I'm old enough. And I still prefer Emacs, but part of that is pre-X11, Emacs was your windowing system, right? And that was insanely productive to be able to say, well, I've got my shell over here, and I'm editing text here, and I'm reading my mail up in this part of the screen. And that was really an Emacs thing. I'm not sure if VI can do that even today. And of course, today it's not that necessary to do. But back then, that was enormously productive to run something like Emacs. The other place you see these mode-oriented things is like the old screen terminals, like from HP, right? Where we had editors like that, where you'd load a whole screen of text, then you edited that screen of text, then you put it back, right? And then you got another screen of text. And all the editing was actually happening in the terminal, not on the computer, which might be downstairs in the basement or something. So I think there's reasons for all that. I think sometimes it's just that's the way we've always done things around here, or that's the first way I learned. I do think we should spend more time thinking about what is the right way to do things and not just slavishly do it the way somebody else did it.
Well, I'm kind of that guy. I used to use Emacs all the time. I must have used Emacs for 15 years before I switched up to Vim. And I switched up to Vim because I wanted to see what that was about. And I've done that for 12 years now. I've written hundreds and hundreds and millions of pages in both of them. And I'll tell you, they both suck. Like, I'll be the first to end the Emacs versus VI war. They both are miserable in their own ways. And with Vim, it really is switching between the modes and forgetting what mode you're in. And until you get used to that, until you're like always type a sentence and get the heck back to normal mode, it just is a weird experience. But then Emacs, and Maya brings this up, and all the other editors, it's unfair to pick on Emacs as the only non-modal one. All the other ones, to make up for the lack of ability to type long commands, you have to have all these crazy Control-Shift-Escape meta X commands, right? Or you have to go up to the menu and you have to mouse around. And neither of these are particularly pleasant to me at all. And I've used the whatever it is, the graphical Emacs where it's got pull down menus, and I've used regular old Emacs where you have to hit Control XS. And both of those are lousy solutions too. And I don't know whether, switch out into command mode so that you can type convenient to type commands is better, or whether this whole you're always in the same mode, so at least you're in one mental frame, but you have to do all these Vulcan nerve pinches to be able to save a damn file. Which one's better? The answer is neither. They're both kind of miserable. And the only thing I know is that I like those better than the ones where you have to lift up your hand, grab a mouse, go up to the file menu and do something.
Yes.
That's the only thing I know. But I frankly, I'm using Vim now, and like you said, I'll defend it against Emacs. I suppose I will. I mean, I really don't care. I think they're both kind of they both have their real weaknesses, and yeah, I think you learn to work with them, and you learn to work around them, and you learn to use the strengths to your advantage, and then just hope to ignore the weaknesses and move on.
Well, and I certainly won't deny that, Emacs has its share of horror. Well, and that's the thing. You do have command mode in Emacs. It's, meta X, right? And then you can type whatever you want. And you can actually do everything. It's just because it's Lisp and it's, verbose. It's like I want to save the file. Well, that's buffer dash saved. So that's
horrible.
Not viable either.
Yeah.
But one thing I always say though is Emacs can emulate VI, but I don't think VI can readily emulate Emacs. So that to me that's a win. Yeah, don't get me wrong. Vim does that. What I'm saying is VI, the original VI, did not do any of that. The original Emacs did all of that. And so that's why I'm so ingrained. Yeah, I didn't mean to imply Vim. Yeah, save the angry emails.
Vim does everything Emacs does.
I understand it does that. But I'm saying, with normal VI, I could not emulate Emacs. With Emacs, I can emulate VI. And in fact, these days, I'm more likely to use Visual Studio Code. But guess what? It has wonderful VI emulation and wonderful Emacs emulation. So I use Emacs inside Visual Studio and I'm done, right? And I still though, if I just want to edit one quick file, I still fire up Emacs. It's and you're right, it's not not because I think it's the best possible thing. It's the best possible thing I have.
8 megs and constantly swapping.
Well, you solve that by having a 64
Yeah,
gig
it's so irrelevant
computer.
now. It's funny. Yeah.
I actually wrote a lot of software using Edlin. And,
no.
I'm sorry, Ed and CPM, and compiled it on a cross compiler. And I told my boss at the time, I said, if you won't buy us something better, I'll buy it out of my pocket. And he said, well, I'm not buying anything. We've had a copy of WordStar for 6 months and nobody can figure out how to install it. And I'm like, what? So I had spent, a year writing code in that editor and then, went to WordStar. Yay. My pick for Can't Miss this week is from Arya Varanova, Logic Analyzers, Tapping into Raspberry Pi Secrets. I have to confess, I'm a little bit of a Logic Analyzer junkie. I've got a bunch, including an old Gould Biomation boat anchor from the 80s that was probably a $400,000 instrument in its day, right? Not that I paid anywhere near that for it. And so I love them, but I think it's really funny that nowadays they're not nearly as useful as they used to be. And the reason is almost everything we do is either serial or it's all tied up inside of a chip anyway. So short of decapping the chip and sticking needles down on the die, you don't really have access to all the signals that you would like to have. But I thought this was a particularly interesting use of the cheap logic analyzer was to kind of go in and sniff on the Pi. But the days that things like my old Gould where, you could have the 100 megahertz clock signal and you got 16 channels and clock qualifiers and all that, there's almost nothing left to hook that kind of stuff to. So really these 1 or 2 channel serial analyzers is what I would think of them are probably way more useful. Then you get into, well, I've got a scope that's got a decoder. Do I really need a logic analyzer? Do I need a mixed signal scope? Or do I just need a scope with enough buffer space in it and some decoders? The nice thing is these days we have all those things, right? These cheap logic analyzers are cheap. They're pretty capable. The higher end stuff's available if you want it. And you do have mixed signal scopes that are affordable. And even the cheap low end scopes now are able to do it quite a bit. So I think it's pretty interesting. Cheap stuff is really leveraged by having really good quality open source software too, because you've got SIGROC, and that's a pretty simple protocol. And if you can talk that protocol, suddenly you've got access to all this graphical output and the protocol decoders and, all these different tools that, frankly, if you're just throwing something together, you're not likely to go put all that software together, but you don't have to. So I think that's another good example of open source being a real force multiplier for us. But you don't really see as much done with that as you used to. And I think it's because there's not that much left to hook it up to.
I think there's much more to hook it up to now because all of these cheap camera modules, nowadays you can lash up a whole bunch of modules you bought on eBay and make a phenomenally capable device that you couldn't have made before. But all of them are hooked together with DuPont connectors. And when something's going wrong, you've got no visibility into why the microcontroller isn't talking to the IMU, or why it's not talking to the camera, or any of the above. And that's where these inexpensive logic analyzers absolutely come into their own. I mean, I have an awesome scope, but it doesn't have good decoders. And like you said, the open source software, huge multiplier because it decodes everything. And I think Agilent, that tells you how old my scope is, wants like $500 for the SPI decoder. And I'm like, that's laughable, right? You just get one of these $6 Chinese logic analyzers and boom, you've got all the decoders you could possibly want for free. I also have a funny story about the production of this article. Arya wanted to write a series about logic analyzers and how to use them to your advantage. And then she started with, I'm going to think up a cool example, and wanted to look at the Raspberry Pi camera. And she ended up with something that I would say is an awesome hack here. Like, the Raspberry Pi cameras are in principle not hot pluggable. And what she's done here is sniff the I2C signal that makes it essentially hot pluggable. By sending this, when you boot up the Raspberry Pi, can get it in the right mode so that you can then hot plug the camera later on. I mean, I think buried in this article that is supposed to be a tutorial on why you should get into logic analyzers is also actually a pretty sweet little hack. So don't pass that up.
My original point, though, is that really this is a serial protocol analysis, which is, okay, granted it's a logic analyzer, but it's not a 16-channel, 250 megahertz logic analyzer, because you almost don't need that anymore, right? You can still get it. And yeah, when you do need it, you really need it. But you're right. I don't need, if I just need to look at 2 I2C lines or 2 or 3 SPI lines, I don't need that. And this is more than enough for that. I will tell you, though, I don't know about the Agilent scope, but a lot of the scopes now have SIGROC drivers that you can load in, grab frames off of it with, SCPI or whatever the protocol is now. And then you've got all those protocol decoders on your scope. I've got several scopes, but the Rigel one that I have, the 4-channel, it's got reasonably good decoders for just about everything. You have to pay for them, but, they're not as expensive as the ones you're talking about. I find that meets 90% of my needs. I rarely need to actually go capture, minutes worth of data. Usually if I can trigger on something and say, okay, oh, look, there's the 10 frames around what just happened. That's plenty for me. And so I usually don't get them back to the PC, but I could, right? Like I say, I can in fact capture the SIGROC from that scope.
Yeah, and there's nothing stopping you from picking up a couple cheap logic analyzers. I actually have both the Cypress FX chip-based one, which I guess was popularized by Saley Logic. I have one of those generic ones. I also have the Logic Shrimp, which has an FPGA in its brain. And the trade-off there is that thing has an extremely shallow capture window, but it's brutally fast. And so if you want to do high-speed short burst stuff, I'll grab that one. And if I want to do low-speed long signals like I2C or SPI, I'll grab the Cypress FX chip-based one. I guess I didn't understand fully what you meant originally when you were talking about logic analyzers, because I wasn't in the game back in the days of the hyper expensive, hyper fast multi-channel ones, back when it was all done in the hardware and was hard to do. So I missed out on that phase. And I guess I don't think of them as being you attach one probe to every line in the bus in the entire computer and you get kind of this bird's eye view of the whole computer. Instead, I'm using it like Arya is here, which is I'm getting in on this one device, talking to this other device and figuring out what's going on there and why it's not configuring it into setup mode right.
I believe, I don't want to swear to this, but I believe the logic shrimp was derived from the SUMP logic
it is.
analyzer. If you look at like sump.org. So I actually wrote some, I don't remember, I think I did some mods for that years back or some software. I don't remember which, but I had some connection to sump.org back with Dr.
Fun.
Dobbs. You know, I've got a couple of those Cypress ones, like you say, and I've also got is it the Logic Cube, or I don't know, the little black one. I actually wrote it up for Hackaday a couple of years ago, and it's great. I mean, it's kind of got the same capabilities of my Gould, but you don't have to put a back brace on to move it into the other room, right? It's just, it's a USB device that weighs less than my phone. There are places for those, but it's funny, like in the old days, the Gould, and I don't have this one, they had a serial analysis module for it, like if you wanted to read RS-232 with it. And instead of hooking up the ECL probes to the RS-232 lines, they had a box that had the matching, paint job and everything that had the RS-232 connectors and a UART, and then broke the UART out to a connector that went to the logic analyzer. So you actually were looking at the serial data in parallel from the UART and configured the UART up. And so now you'd go the other way, right? You'd actually watch the serial lines, pick them up, and do the decoding in software. But those old logic analyzers were beautiful. And if you had expensive ones, because they were very expensive, the big thing to do was to watch a CPU. You'd clip over the CPU chip, watch the address and data buses. A lot of them had floppies, and you could buy like, okay, I'm on a Z80, so I put the Z80 module in, and it's going to show me the instructions, and it's going to show me so it was almost like having in-circuit emulation at a big cost, but a fraction of the cost of what real in-circuit emulation cost back in those days. So anyway, cool stuff. But I did love the article, and I do think it's an underappreciated technique. And I also think her hack is, like you say, it's hack-worthy all by itself.
There's going to be at least an Article 2 in this series, maybe even an Article 3 and 4. So if you want to expand your abilities to use a logic analyzer, you should stay tuned to Hackaday.
Well, and I challenge you too. Leave us in the comments. What are you using logic analyzers for? I think that'd be an interesting topic too.
That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you want to follow the links or comment on the show, head on over to hackaday.com/podcast. If you see anything cool or do anything cool, send us a tip, tips@hackaday.com. And until next week,
keep those hacks coming.
And what do I want to say?
I'm pretty sure at the end you're going to hear blah, blah, blah now, right? Is that?
Oh, yeah, that's true. Blah, blah, blah.
We probably should have an electrolytic capacitor exploding. That would be
Oops, dropped my mic.
Supposed to wait till the end of the podcast to drop the mic. I'm going to excuse myself on that one. So
I'm going to cut all that out. That's just...
Let's start that one over.
Oh, you cyborgs. And this week I got via Posh. And that's it. Now we're done. Thank you very much, sir.